Okay, we're talking yesterday, today, and tomorrow, right triangle trig. All right, right triangle, right triangle, right triangle. That means 90-degree angle in the corner, okay? You guys are going to be talking about, we're going to be talking about word problems. A little bit today, all day tomorrow. We're just going to be talking about word problems. The math behind the word problems is easy. It's the setting up that sometimes gives you guys a little bit of issue. So that's what we're going to work on tomorrow, is talking about what they're looking for, what information they're giving us, okay? When you are told on any given problem to solve a triangle, right? To solve. They don't have to say, find side A, angle B, whatever. When they say solve, you need to find all the stuff that's missing, okay? A triangle has 6 parts, 3 sides and 3 angles. So if they give you 2 angles and 2 sides, you're going to find 1 angle, 1 side. If they give you 1 side and 2 angles, you're going to find an angle and 2 sides. But when it says solve, you have to find everything that's missing. They're not going to specify what you need to find. So like I just said, we're going to be talking about right triangle trig. So every word problem that we do today, tomorrow, probably a little bit on Friday, you should draw a right triangle. And we're going to have to decipher where they're talking about the information, what information they're giving us. When they use words like how tall or the height of something, they're talking, I'm going to call it the Y, the vertical. When they talk about the height, how tall is something? How high in the air is the balloon? How high in the air is the plane? Something like that. They're talking about the vertical, the up and the down. When they're talking about the horizontal, which we'll call it the X, they're usually talking about distance between things, like distance between. Also, a lot of times in word problems, they'll talk about shadows. When you're standing in the parking lot and your shadow is cast, where do you see your shadow? On the ground, right? It's always on the ground. So when they talk about a shadow is a certain amount long, whatever, that's the X value. Whenever they're talking about the hypotenuse, a lot of times they'll talk about a ramp. Got to build a ramp, an escalator, a ladder. You know, a lot of times you'll see a fire truck has to go rescue someone in a 85-foot tall building. How long does the ladder have to be? Think about where a ladder would be. It would be leaning against. That would be your hypotenuse. A lot of you guys drive, correct? So you're driving along 75, and they just put in just nice, beautiful palm trees. And then they have like those 2x4s that are holding the tree up like this till it like takes root. You guys know what I'm talking about? You guys have seen that? A lot of times they'll give you a problem and they'll talk about a guy wire. A guy wire acts like those 2x4s. It's usually tethered to something and it keeps it holding up. So a guy wire, if you see that in a word problem, is talking about like the hypotenuse. Just to give you guys a visual of what they're talking about. All right. So here is a triangle and it says to solve it. So let's think about what we have to find. We have to find side A. We have to find side B. And can we find angle B? Yeah, how many? Perfect. How many degrees are in one whole triangle? 180, correct? There's 180 degrees in every triangle. Well, there's 90 degrees right here in this corner. There's 30 in the other one. So 90 and 30 is 120. 180 minus 120 is. So angle B is 60 degrees. Now, once you guys, there's lots of different ways to find answers to these questions, right? We know our trig functions, and we have different angles, so you can look at different trig functions. But I was given 30 degrees. In regards to 30, what is A? Is it the opposite? Is it the adjacent? Or is it the hypotenuse? A is the opposite side, okay? B is the adjacent, correct? And 12 is my hypotenuse. So if I wanted to use the hypotenuse and 30 to find the length of side A, what trig function would use opposite and hypotenuse? Sine. So I could say the sine of 30, which is some value, equals the opposite side, which I don't know, over 12. You're just setting up a proportion. How do we solve proportions? When a fraction equals a fraction, how do you solve it? You cross what? Cross multiply. So A equals 12 times the sine of 30. So in your calculators, guys, what is 12 times the sine of 30? 12 times the sine of 30 is 6. So you guys just solved this, that A equals 6. So we found angle B was 60 degrees. We found side A is 6. So now we can find side B. Well, how could I find side B? If I know that the hypotenuse is 12, and I know that one of the legs is 6, how could I find the other leg? A squared plus B squared equals C squared. So I know that A is 6, so 6 squared plus B squared equals 12 squared. What's 6 squared? 36 plus B squared equals 144. Subtract 36 from both sides, and I get B squared equals 108. So how do I figure out how long B is? I'm going to take the square root. So B equals, well, we got to break down 108. What's the biggest perfect square, non-perfect square that goes into 108? No, we can break it down. Use your calculators. Try and break it down. What goes into 108? 12 and 9. Agreed. Anything bigger? Because 9 is a perfect square, but there's a perfect square inside of 12. What's the perfect square that's inside of 12? 4. What's 4 times 9? 36. See if 36 goes into it. (36 times 3). So when I break this down, I get 6 root 3. So B is 6 square root of 3. So we just solved the triangle. If you guys notice, angles in a triangle are written with capital letters. Sides are written with lowercase. It's important to notice. But when you're asked to solve a triangle, you can use your trig functions. Once you have two sides, you can use the Pythagorean theorem. But you don't always have to use the same trig function. If somebody wanted to find B, you could have said cosine of 30 equals B over 12. Because you had enough information to do that. So we're just going to practice that a little bit more later. When we talk about the line of sight, guys, your line of sight is when you're standing and you look straight ahead. It's like that invisible line that is formed. So see if someone is standing, the horizontal is like where you're looking. Your line of sight, if you are looking upwards, you're creating an angle of elevation. If you tilt your head up, then your eyes have created an angle of elevation. Everybody understand that? Mm-hmm. If you're standing and then you look down, then you have created an angle of depression. So your line of sight is when you stand and you look straight ahead. That's your line of sight. So if you look up, you're creating an angle of elevation. If you look down, you're creating an angle of depression. That should kind of make sense to you guys. So we're going to have word problems, and they're going to give you something that says, like, the angle of elevation is this. The angle of depression is this. The thing that is important to understand. And again, you guys are going to draw right triangles for all of these word problems. I always draw my right triangle the exact same way. I don't know why. I just always do. If you get in the habit of doing that, that's fine. An angle of elevation it goes up. So a lot of times it's formed, they'll tell you the angle of elevation's formed from the ground. It would be down here. This would be your angle of elevation. Because think about it. Elevation. Think about it. From the ground, what happens to your line of sight? You're looking which way? Up, right? It's creating it upwards. Angle of depression, a lot of times, someone is standing and looking down at something. So when here is the line of sight, the angle of depression is outside of the triangle. So sometimes, this is your angle of depression, right? If you guys are given the angle of depression, you can look at it two different ways. The angle of elevation is created generally with the ground, and it's inside the triangle. Your angle of depression is outside the triangle. So think about this. If I told you that the angle of depression was 35 degrees, does 35 go in the corner? No, it goes outside of the triangle. So what number would go inside the triangle? How much is inside the triangle here if the outside angle is 35 degrees? Anybody know how to figure that out?
55.
It'd be, how'd you get that? 90 minus, good, 35, so it'd be 55. So your angle here would be 55 degrees. Now, if you guys don't like doing the 90 minus and putting that angle up there in that corner, that's fine. I could say, well, if the angle of depression is 35 degrees, does anybody remember anything from geometry? When two parallel lines are cut by a transversal, their alternate interior angles are what? They're what? Not inverse. They're not opposite. They're the same. So if they give you an angle of depression from the top, you can also, right, look, my angle of depression is formed up here. Well, back in geometry days, two parallel lines cut by a transversal, alternate interior angles are congruent. So you can either say 90 minus and use this angle up here in your triangle to get your angle that's inside, or you can say that your angle of depression is equal to the angle of elevation at the bottom of the triangle. Does that make sense?
Yeah, and the depression line is just the one that's going down, right?
Yeah. Yep. So either way you look at it, it's not 35 though. If you're going to put it up from the top, it's 90 minus. If you're going to put it inside at the bottom, it's the same angle. So a lot of times, you guys, and this is what we're going to work on tomorrow, you guys are going to get word problems. You will not have a picture, all right? You're going to have to draw your own. So we're talking about right triangle trig. So the first thing you should do is draw a right triangle. Like I said, draw the same triangle. I always draw just facing this way. I don't know why. But you understand if you get into the habit of doing the same thing every time, it makes things a little easier. If you need to draw yourself a picture, draw a little picture. A giant redwood tree. Okay, did they say that the tree was laying on the ground because it was struck by lightning? No. They just said a giant redwood tree. So there's my tree. That's the vertical. You guys see that? It says it casts a shadow 532 feet long. Where is 532? The bottom. Because where are shadows? On the ground. 532 feet. They didn't say the tree is 532 feet tall. They want you to find the height of the tree. What are we looking for? The green vertical, or are we looking for the hypotenuse? Green vertical. We're looking for this. What is the angle of elevation or depression that I'm going to use? Okay, find the height of the tree at the angle of elevation. So that means where is 25.7? On the bottom. The angle of elevation is 25.7 degrees. What trig function would I use? Well, what do we have? In regards to my angle that was given, 25.7, what is x? It's the opposite side. And what is 532? The adjacent side. What trig function uses opposite and adjacent? So I would say the tangent of 25.7 equals x over 532. Now, if I just gave you tangent 25.7 equals x over 532, every single one of you could cross multiply and throw that in a calculator. It's the matter of being able to set these problems up. That's what we're really going to focus on tomorrow. So you'd cross multiply. You have 532 times the tangent of 25.7 equals x. Round to the nearest foot. What's 532 times tangent 25.7? 256? So it's about 256 feet tall. Now, when you guys do these word problems, you should also take a second and check. Just to make sure your answer makes sense. If you came out, they said that this giant redwood tree casts a shadow of 532 feet. You guys came out with your answer of 0.134. Does that make sense that a giant redwood tree is not even 1 foot tall? No. So just make sure you guys are understanding that your problem, your answer should make sense. Just to bring something up, just say that they give us the information that the hypotenuse for whatever, a ladder leaning against a house is 12. How far is the base of the ladder? And my angle of elevation is 37. All right. What do I have here? In regards to 37, what is x? In regards to my 37, in my picture, what is x? The adjacent, good. And what is 12? The hypotenuse. So what trig function uses adjacent and hypotenuse? Cosine. So I'd say cosine 37 equals adjacent over hypotenuse, correct? How do I solve this? Cross multiply. So we get x equals 12 times the cosine of 37, correct? What is that in your calculator? $9.58. Okay, so x is 9.58. All right. What about if I have the same problem, but they tell me different information? They tell me that the angle is still 37 degrees, but they tell me that the adjacent side, the distance from me to the building is 12 feet. How long does the ladder have to be? Right? Different, same exact type of problem, same exact numbers, but we're looking for something different. What is 12 here? Adjacent, right? What is x, your hypotenuse? How do I set this up? Cosine 37 equals what? 12 over x. Am I going to get the same answer here? No. Do we still do the problem the same way? Yes. Cross multiply. You get x times the cosine of 37 equals 12. Guys, when you solve any equation, you want to get x where? By itself. So what's the opposite of x times cosine 37? Divided by. Remember, the cosine of 37 is just a number. It's just a gross decimal. So that's like saying 3x equals 12. You would divide both sides by 3. This just says x times cosine 37, so you're going to divide. So here we get x equals, what is 12 divided by the cosine of 37? Do it in your calculator. 15.02. All right, same information, same angle of elevation, but we were looking for a different piece of the triangle, so our answer is different. Our setup was just a tad different. Your variable was in the denominator versus the numerator. So we're going to work tomorrow. I just have a bunch of word problems. The biggest thing that I want to focus on is getting them set up. Everybody in here can cross multiply and punch numbers in the calculator. But to get the problem set up so you understand what is given to you and what you're looking for and where to put it on the triangle, that's what we're going to really focus on tomorrow. Okay?